And good morning, math masters of Virtual Room 502. Remember, yesterday we were talking about factors, numbers that we can multiply to reach a certain number. Remember, we talked about 18. We could go 18 times 1, 2 times 9, 3 times 6, and that was all we had. So the factors of 18 were 1, 2, 3, 6, 9, and 18 itself. Going to do some more of that. And today we're going to identify factors to define prime and composite numbers. Okay, we talked about those two terms a little bit yesterday. We didn't really get into it too much, but prime and composite. Okay, let's think about how we're going to start this off. Let's go with the number 16. Okay, remember we made some arrays the other day. Get this thing off there. So let's go ahead and start with 16. 1, 2. Oh, yes, and right now you are indeed. You know what I'm reaching for. You are copycats. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And what does this stand for? Well, it stands for 1 times 16, and that equals 16. And now we know that 1 and 16 are factors of 16. What else can we do? Let's go with 2. 2 times a number is 16. Well, let's think about it. 2 times 1, 2 times let's just do like this for fun. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 3, or excuse me, 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, and 2 times 8 is 16. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have 2 times 8, and that equals 16 as well. So 2 times 8 is 16. What else can we do? Can we do 3? 3 times a number? When I think about threes, let's just kind of do a little skip countdown here. 3, 6, 9, 12, 15, 18. No, you can't multiply 3 by another number to get 16. Let's put 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And 4 times 4 is 16. So let's set up that array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we have 4 times 4 also equals 16, right? 4, 8, 12, 16. So now the factors I have are 1, 2, 4, 8, and 16. What about 5? Would that work? Let's think. 5, 10, 15, 20. Nope. What about 6? 6, 12, 18, 24. No. 7, 7, 14, 21. That's not going to work. What about 8? We know works, right? 8 times 2 is 16. So we don't need to go any further because 8 is the halfway point, right? 9 times 1 is 9. 9 times 2 is 18. We can't get that into 16. So these are the factors of 16. And we'll model it like this. We'll go 1, 2, I don't see any 3. We go to 4, right? 8, and 16. And we know that 1 multiplied by 16 equals 16. 2 times 8 is 16. And then 4 times itself, make a little up arrow, is 16. So these are all the factors of 16. 1, 2, 4, 8, and 16. And we call this number a composite number. Say that out loud. Composite. We call it composite because it has more than 2 factors. It has 1, 2, 3, 4, 5 factors. 1, 2, 3, 4, 5 factors. So what about a prime number? Okay, what makes a prime number a prime number? Let's look at the number. Here we go. Ready? We're going to look at 1, 2, 3, 4, 5, 6, and 7. And we're still copycats. What? To prove it, I'll have the copycat make a second appearance. The cool copycat. There he is. Hello, copycat. So we have here 1 times 7. Now, if you note, no matter what I do, I can't find another number to multiply other than 1 times 7 to get to 7. Look, I can't do 2, 2, 4, nope. I can't do 3, 3 times 1 is 3. 3 times 2 is 6. No, not going to work. I can't do 4. 4 times 1 is 4. 4 times 2 is 8. 5. 5 times 1 is 5. 5 times 2. No. 6, of course not. 6 times 1 is 6. 6 times 2 is 12. So this only has, the number 7 only has 2 factors, 1 and 7. And this makes it a special number called prime number. The thing about prime numbers, the only factors they have are the number 1 and itself, so 7. Those are the only 2 factors they have. Nothing else, not more than 2. That's all. Let's take a look at another prime number. And we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here we have 1 times 13 equals 13. And you're still copycats. So can we do 2 times something equals 13? Look, 2, 4, 6, 8, 10, 12. Nope. How about 3s? 3, 6, 9, 12. That's not going to work. We'll get another colored pencil, see if we can find another factor. Any factors of 13. Oh, here we go. Let's try it 4s, okay? 1, 2, 3, 4. Okay, that's one group of 4. 1, 2, 3, 4. You don't need to get colored pencils to do that. 2 groups of 4. 1, 2, 3, 4. 3 groups of 4. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, and not a factor. 4 can't be a factor of 13. What about the 5s? What if we were looking at the circle of the 5s, and you guys, once again, don't need to get special crayons out for this. I just want to show you something. We have 5, and then 1, 2, 3, 4, 5, and then 10. Right? And look at 15's next, so we can't do that. 6 isn't going to work because 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 7, nope. 7 times 1 is 7. 7 times 2 is 14, and so on and so on. So the only factors of 13 and 7 are 1 and the number itself. So that's what makes them prime numbers. They have no factors other than those 2, 1 and themselves, and they're prime numbers. On the other hand, on the flip side, take a look at a number like 16. We have 1, 2, 3, 4, 5 factors. We can do these combinations. 1 times 16 equals 16, 2 times 8 equals 16, and 4 times 4 equals 16. I know this gets a little confusing, but keep practicing and we'll be able to identify composite and prime numbers. Just you wait and see. Wait and see. Wait and see.